Hello, my name is Leopoldo Armesto, and in this presentation I'm going to explain about sensors that we typically use in IoT applications. So this is the outline of our presentation. So we're going to explain you about light sensors, temperature sensors, moist sensor, rain sensor, also gas sensor, and barometric pressure sensor. And finally, we are going to explain also about the radiation sensor and many other alternatives too. So the light-dependent resistor, also known as LDR, is a resistance that varies depending on the amount of visible light received. So typically we use this sensor to measure the light in our home or in a greenhouse. And we typically need not just simply the resistance provided by the LDR, but also another resistance, so it acts as a voltage divider, as you can see here in the circuit application. Here you can see also the one of the most known modules, which is the KY18 module, which already provides all the necessary electronics and 3 pins for providing the power supply, the ground, and the signal itself. It might require calibration because the relation between the voltage and the luminance is non-linear, but this depends on your application. If you really want to measure the luxes, you need to calibrate it, and then it's a different procedure. Then we have different kind of temperature sensors. We have the DHT11, which is a digital sensor and provides the humidity and the temperature in Celsius and with degree precision, so it's not under a degree. And this uses one digital signal for transmitting and receiving data. And here you can find the KS module, the KY15, which provides again 3 pins for power, ground, and the signal itself. Also, we have the LM35 sensor, which is an analog temperature sensor, and the main characteristic is that it provides a linear response. So it has a resolution of 10 millivolts per degree, and the position is quite small. So it means the precision is high. It means that the resolution between one measurement and another one it's even from 0.5 degrees. And it has an acceptable range for all the kind of applications that we want to deploy. Also, we can find the sensor from Dallas company, which is called the 18B20. It uses a specific interface which is called one-wire interface. This interface allows us to put several sensors just simply using one wire bus, and it measures Celsius and Kelvin degrees, and also provides handlers for alarms. Here you find also the KS module, which is the K1001. Then we have the moist sensor. So we use this sensor to measure the humidity of the soil, and so it's just simply an analog output. It provides an analog output, so this signal is proportional to the resistance of changes of the soil moist. And also together with the provided electronic, we have also a digital output. So we have a potentiometer that we can adjust, and depending on the value we set, there is an analog comparator in which we can have some kind of threshold, and then we can use this digital output. So whenever the humidity is above or below that value, the digital output will be high or low correspondingly. So we have also a rain sensor. Is very similar to the previous one. The difference is that we have this panel which basically it's providing some kind of short circuit resistance. So depending on the amount of rain that you are receiving, and also provides the analog output and the digital output interface. So the analog output is proportional to amount of raindrops that you're getting with this sensor. and the digital output can be activated or deactivated depending on the potentiometer value. So then we have different kind of sensors. They are called MQ gas sensors, and they are different type of sensors depending on the gas that we would like to detect. There are many type of gases that they are able to detect, like LPG, butane, propane, methane, alcohol, fumes, etc. And the basic principle is that they have some kind of aluminum oxide ceramic tube and a sensitive layer. And it has an electrode and a heater, so it needs sometimes before it's operational and reaches the appropriate temperature to really measure the appropriate measurement. It is very interesting to mention that these kind of sensors, they just simply provide an analog output based on this on the receive the amount of particles of gas that you are detecting. And if you really want to measure a specific gas in particles per million, then you need a calibration procedure in which you need to basically calibrate it first with a cleaner environment. Then we have also the barometric pressure sensor. It's able to measure the absolute pressure of air and provides ranges between 300 and 1100 pascals, and it provides also the altitude and the temperature. And the altitude depends, or you can set the altitude depending on your location. And the nice or the interesting thing here is that it's using the I2C interface, so it uses basically two signals. Also, we have the radiation sensor. With this sensor, we can measure the ultraviolet light. And in this specific sensor, the GUVA S12SD, it's an analog interface and provides measurements for line ranges between 240 and 360 nanometers. And there's an equivalence between the measured value and the UV index. So we can use this sensor as a way to measure the kind of radiation we are receiving in our environment. And obviously there are many other kind of sensors that we can use in IoT applications, like RFID car readers, camera, or different kind of contact or barrier sensors too. Okay, but this presentation was intended to describe the kind of sensors that we can use in our home automation or our greenhouse or weather station projects. Okay, so thank you very much for your presentation, and I hope to see you on my next presentation too. Thank you.